Chapter 6, Day 2. We're going to start with the 45. I'm going to go a little bit out of order. So it says, Darren wonders if he can discover a pattern in another special triangle. So they start with 30, 60, 90s. But I think it makes more sense to start with 45, 45, 90. I think they're easier for most kids to remember. So we'll kind of jump into this. So they've already sort of worked with this and discovered a pattern, but we'll do it together. It'll be fine. So it says, use what you know about the triangle to help determine the lengths. Darren determine the lengths of sides A and B without a trig or a calculator. So here's what I'm going to do. Well, if it's a 45-degree angle and this is a right angle, this also must be a 45-degree angle. And so we have an isosceles triangle. So the angles are the same and the sides are the same. So that means that side A must equal 1. And now I can use the Pythagorean theorem to say that a squared plus, well, this is b squared, but we'll call this b squared, the leg squared. The leg squared plus the leg squared is going to equal the hypotenuse squared. So 1 plus 1 equals b squared. 2 equals b squared. We're going to square root both sides. Because remember, a square root destroys a square. And there we go. We're going to get the square root of 2. So it says leave your answers in the exact form. So we're not going to go ahead and call this like 1.7 something. We're going to just leave it as the square root of 2. So kind of an interesting thing here. I notice a pattern in that if you give me one side of a right triangle, 45, 45 triangle, one leg, the other leg must be the same. And then I can just multiply by the square root of 2 and I'll get the hypotenuse. So what should we name this triangle? We should name it a special right triangle of 45, 45, 90 triangle, I think would be a good name for it. Special right triangle, 45-degree triangle. Are all triangles of this type similar? Yes. They all have angle similarity, right? So the sides are all going to be proportional. So what does that mean? Well, that means if you give me a triangle like this, I should be able to say, well, this leg is 20. Well, this leg must be 20. And this hypotenuse must be 20 times the square root of 2. It's known as 20 rad 2, radical 2. And I know this is true because 20 squared plus 20 squared should equal 20 times the square root of 2 squared. Now, an interesting thing happens. I think this is pretty cool. So think about this. I'm just going to leave this like this, 20 squared plus 20 squared. I'm not even going to do the math on this because what's going to happen here is I'm going to get 20 times the square root of 2 times 20 times the square root of 2. Hopefully you see there's 2 of these. Well, I'm going to just leave the left side the same, so I'll just keep going down here. So if this is all multiplying, right? And multiplication is commutative. 20 times the square root of 2 is the same as the square root of 2 times 20. So I can change the order here. Right? And I know that 20 times 20 right here is 20 squared. And I know that the square root of 2 times the square root of 2 is the square root of 2 squared. And I know that a square root and a square undo each other. So what I'm saying is that square root of 2 times square root of 2 equals 2. So I have 2 20 squareds. Well, guess what I have over here? I have 2 20 squareds. So that's always going to work, right? I went through a very long explanation of this. I would never expect you to do all this math. But I want you to see why this works. Like, it's very simple, right? I'm just saying, oh, look, here's a 20 squared and here's a 20 squared. And if I multiply these together, I'm going to have 2 20 squareds, which is what I have here. So I don't need to even do the math on this to know that this is true. But if it, I know some of us either aren't following what I'm saying or want to see it. So I will do this. I know that 20 squared is 400 plus 400. And then 20 times the square root of 2 is going to be 800. If you don't believe me, I will grab this calculator. 20 times the square root of 2. And I want to square this thing. So I'm going to get that. And then I'll square it. And you can see I get my 800, which is what I said I would get over here. So there we go. Kind of a neat little trick. Works out nicely. So let's go ahead and keep looking over here. So this is how easy these are. Now that we know how this works, hey, look, this is 5. This must be 5. and this must be 5 square root of 2. That simple. Again, you can do all the math over here if you don't believe me, but what you're going to find is that 25 plus 25 equals 50. That's what you're going to get. 5 squared plus 5 squared equals 2 5 squareds. Same idea. Let me pause and set up the next page. We're going to get this graphic organizer, and as you can see, this one's already filled out, x squared of 2. We'll talk about the 30, 60, 90 later. Right now we're focusing on 45, 45, 90, but what happens if we get one like this, and really focusing on these first two? As you can see, we get to 30, 60, 90, which we'll talk about in a different video. So what do we do if we get something like this? So what if they give me a leg, and again, this is a 45-degree triangle, so 45, 45, 90 triangle, and they give a leg, but I need the hypotenuse. So in this situation, when they give me a leg and I want the hypotenuse, I'm going to multiply the leg by the square root of 2. Right? So I'm going to say 7 times the square root of 2 equals 7 square root of 2. Hopefully yours looks a little bit cleaner than, oh jeez. Ugh. Hopefully yours looks a little bit cleaner than mine. But there we go. We already know this. But what happens if this one's a little bit different? So again, we have a 45, 45, 90. And what I would love is if you guys fill this thing out and have this. So I'm not going to give you anything other than what shows up on the sheet. Every single scenario will be on the sheet. And if you ever get confused what you're supposed to do to solve it, you can kind of look at this. So what if you have a 45, 45, 90, or they give you the hypotenuse? Now they give you the hypotenuse. And you need the legs. Well, we're going to do the exact opposite. Instead of multiplying by the square root of 2, I'm going to divide the hypotenuse by the square root of 2. So think about it up here. If you had given me this hypotenuse of 7 times the square root of 2, I would have just divided, right? I would have just divided 7 times the square root of 2 by the square root of 2, and I would have got my leg as 7. So I hope that kind of makes sense for this one. This is going to be different. But for this one, you can see if you give me the hypotenuse, so they hadn't given me the legs, but they had given me the hypotenuse first, I could have got you my legs by dividing by the square root of 2. So now what I'm going to do is I'm going to do the same thing here, but I need to divide 7 by the square root of 2. Now, if you think about where we started this chapter, I can't have an irrational denominator, so I'm going to multiply by the square root of 2, right? And I'm going to get 7 times the square root of 2 over 2. And this is what my leg is going to equal. So my legs here are going to equal, again, this is 45, this is 45, this was 7. My legs are going to be 7 times the square root of 2 over 2, and 7 times the square root of 2 over 2. I know a little bit kind of confusing and a little bit maybe disconcerting, but think about it. What I'm really saying, what is 7 divided by 2? Isn't it 3.5? So if I have 3.5 times the square root of 2, right, this is a fancy way. 7 times the square root of 2 over 2 is a fancy way of saying 3.5 times the square root of 2. Hopefully we all agree to that. Well, if I were to square this, actually, yeah, never mind. I'm sorry. So if I want to multiply this, we know that if you give me a leg, I multiply it by the square root of 2, and that'll give me the hypotenuse. Well, it's 3.5 times, what's the square root of 2 times square root of 2? 2. So there we go, we get our 7. I know that's a little bit kind of confusing. That's why I'm giving you guys this graphic organizer, so you can, hey, they gave me an hypotenuse, so what do? I divide by the square root of 2, and then I get my leg. Hey, they gave me a leg, I need the hypotenuse, what do? I multiply by the square root of 2. Hopefully you can see why I'm giving you this, and it's one of those things where the more practice you get, the easier it'll get for you, and you probably won't even need this after a while. Let me pause and set up the rest of this video. It's going to be, not surprisingly, some 45 to 45, 90-degree triangles, and how do we go about solving them. So here, if I solve for x, I know it didn't ask me to solve this, but I know this is 8, this leg is 8. And then, hey, look, I have a situation where they're giving me the leg and I want the hypotenuse. So I'll run back over here and look at this. And if they give me a leg and I need the hypotenuse, I need to multiply the leg by the square root of 2. So I'll go back over here. I will multiply the leg by the square root of 2. And that must be what I'm getting for my hypotenuse. Now, what about if I get a problem like number 4, where they give me the hypotenuse and I need the legs? By the way, I know this is a 45-45 triangle because if the legs are the same, the angles must be the same, right? And there's only one way to split up 90 degrees to make them the same, and that's 45-45. So in this example, they give me the hypotenuse, I want the legs. So again, I'll go back over here, and you can see if they give me the hypotenuse and I need the leg, I'll divide the hypotenuse by the square root of 2. So I'll go here, I will take 18, I will divide it by the square root of 2. I can't have an irrational denominator, so I will rationalize it. I get 18 times the square root of 2 over 2. I'm going to have to simplify this, right? 18 divided by 2 is 9. So there we go. These must equal 9 times the square root of 2. And again, if you want to check that, we know that if you're given a leg, you multiply by the square root of 2 to get the hypotenuse. So what would be 9 times the square root of 2 times the square root of 2? Well, it would be 9 times 2, which would be 18. So you can see that works out quite nicely. So moving along, we get a couple of word problems. I know this one can be a little bit tricky, but I don't think it's that bad. If the perimeter is 48, I'll give you a little bit of a hint. If the perimeter is 48, each side has to be the same because it's a square, so that means that these are all 12. And it says find the diagonal. Well, if it's a square, this must be a right triangle, right? So same kind of logic here, so we can use some math there. And then, again, just to end it, same kinds of things. We need to solve for the x and the y. So if this is 45, and I know that my hypotenuse is 7, I'll go back over here. If they give me the hypotenuse and I need the leg, I'll divide by the square root of 2. So I'll go back over here, and I will divide 7 by the square root of 2. I can't have an irrational denominator. So I will get 7 times the square root of 2 over 2. And that is going to be true for both of these. So I hope that makes sense on how that works. I know it's a little bit tricky at first, but once you get the hang of it, it's pretty easy. And then we'll introduce 30, 60, 90 triangles and go from there.